Okay, hello, this is Max, working on fall 2014, question 5b. Cross out as many lines as possible in the implementation of FibLink class so that all doc tests pass. A FibLink is a subclass of link that contains decreasing Fibonacci numbers. The up-to method returns a FibLink instance whose first element is the largest Fibonacci number that is less than or equal to a positive integer n. Alright, okay, cool. So let's take a look and see how. Let's first see how the doc tests use FibLink. That'll give us an idea of what's happening. Okay, so 10 is equal to FibLink 2, FibLink 1, up to 10, and 10 is 8, 5, 3, 2, 1. Okay, so we're generating we're sort of generating additional Fibonacci number, or Fibonacci links, right? Oh, interesting. Okay, so we're generating a link that has an initial starting Fibonacci number set. And up to 10 is going to give us everything that's less than 10. Awesome. And we're able to do 10.up to 1. This is still just an instance of link. And so 10 is an instance of FibLink, and so we're able to still use up to on it. Okay, that's fine. 613. Okay, cool. Alright, so let's take a look. So success is equal to self.first plus self.rest. At property, so we don't have an option there. Define successor. Well, so if it's a method, it's got to have a self. So we can cross that off right away. And now we have first plus rest dot first. This doesn't have an init in it at all, but it inherits from link, so we're fine. And first is, we've sort of lost first if we don't use a self, so that's a no-brainer as well. Up to n, this is another test. Are you using self? Do you know what a self is, right? And here since we call it with this 10, we must use a self. Now we have a few options. Okay, so while self.first is greater than n, we're going to set self equal to self.rest.first, self equal to rest, self.first. Oh my goodness. This is a lot of stuff. Let's look. While self.first is greater than n. So what do we really want to do with up to? With up to, it seems to me that we're starting with something that has. So the up to method returns a FibLink instance whose first element is the largest Fibonacci number that is less than or equal to a positive integer n. Okay, so I guess we have a few cases here. So while self.first is greater than n, we really want to sort of like return our smaller integers. So we'll say self is equal to self.rest.first doesn't make a lot of sense because we actually want to return a link, and first is going to be some number. Self is equal to rest doesn't make sense because we're not doing our instance attributes. We're not doing our instance attributes correctly here. Uh-oh, this could be bad. Self.first is equal to self.rest.first. That might be it, but then you keep track of all your self.rest stuff. So maybe I made a mistake somewhere earlier here. Self is equal to self.rest.first. Is that possible? That doesn't make a lot of sense to me. Well, self.first is greater than n. Self is equal to rest. Seems like the natural thing, but really I would want it to be like self is equal to self.rest. Maybe that'll happen later. Well, self.first greater than or equal to n. If self.first is equal to n, return self. Okay, that sounds right. Else if self.first is greater than n, return self.up to n. Alright, so I think maybe we can just cross that whole thing out. That sounds right, and I think we're going to cover this case here. So return self.up to n. Okay, so self.up to n is, and it takes a positive integer n. Okay, good. So if self.equals n, I think this looks right. Else if self.first is greater than n, we're sort of covering this case here. return self dot up to n is going to do exactly the same thing, and that doesn't make any sense. Self dot rest dot up to n is going to sort of cut our it's going to cut off the first element of our linked list. And so if we give it 8 5 3 2 1, we'll call self dot up to on 5 3 2 1, which is what we want to do. Okay, now we have sort of two options for else if. We're going to cross off one of these. Well, so this, I mean, this doesn't make any sense because our else case is just going to catch this. So else if self.successor is greater than n. Yeah, okay, so if self.successor is greater than n, this means that if we were to continue building our Fibonacci link, so if you imagine this link right here, right, link 8 5 3 2 1, the successor of this, the next thing that this would create would be 8 plus 5 is 13, which is greater than 10. And so in this case, we sort of can say we're done iterating and we're ready to just return ourselves. Okay, now we get into the case of, okay, now I need to actually build up I need to add more things to my list because I'm less than the n that I'm trying to get to, and I can keep building up. So what do we want to do? We want to build a new fib link. And since we've made it a property method, we don't need to do self.successor self. That doesn't make any sense. So anything with self.successor self seems wrong. Return self.successor, comma, self.rest up to n. This doesn't seem right because then we're missing out the first element, which is important in our Fibonacci link. And so we're going to just have that. Okay, and so those are the lines you should cross off. And hopefully that explanation was clear. If not, please, please, please feel free to leave a follow-up in the comments on Piazza or on YouTube, and we'll get them cleared up. Thanks for watching.